Hello, this is Matt Montgomery, Sales Agronomist with Burris. Welcome to session number 2, part 2 of our 8-part series on sulfur. We're going to talk about this nutrient, how it's used by the plant. We're going to talk about it, how it comes into the plant. We're going to talk about how it leaves the soil cycle. We want to remind you, though, as we begin today, where we are in the overall list of topics that we are going to cover. On that topic, last time we talked about basic information. What does the plant use sulfur for? Why is it important? We also talked about the series theme, the phrase that we're going to go back to time and time again to kind of govern what we talk about. And we talked about how sulfur enters into the soil sulfur cycle. And we're going to review that topic of entry one more time before we move to today's topic, which is plant availability. This is that governing theme for this series. Always, always, always look to the cycle. The soil sulfur cycle can help us answer many of the questions that we have about this nutrient, and that's why we're going to the trouble to learn about the soil sulfur cycle. We cautioned last time, and I will caution again, not to get too overwhelmed by this picture right here. This is the soil sulfur cycle, and it looks really, really complicated. We said last time what we're going to do, though, is break it into little pieces, into bite-sized sections. Last time we talked about entering the cycle, and we said there were 2 primary pathways in. Those 2 pathways in were through fertilizer or through atmospheric deposition. So those really are the 2 major sources of entry for sulfur into the soil sulfur cycle. Atmospheric deposition, sulfur falling out in the form of acid rain onto fields, or fertilizer applied intentionally or unintentionally. Now we can move on to today's topic. So we were talking about plant available sulfur. That's today's topic. And so let's just begin this with a question. How is sulfur primarily taken up by the plant? And remember our answer to everything. It's going to be that. Look to the cycle. So here's plant uptake. The plant actually taking up sulfur to help make amino acids, to help with enzymes, all those things we talked about in session 1. Let's just work our way backward and see what plant uptake requires. You can see right here that for sulfur to be taken up by the plant, it really needs to be in the sulfate form. That is the big way that sulfur is taken into the plant, is in the form of sulfate. We mentioned this last time, but we're going to go just a little bit deeper into the topic this time. Sulfate, so this form of sulfur that tends to be the way sulfur is actually taken into the plant, is negatively charged. Now this means it's not held very well by the soil, and you can see over here on the graph on the right why that would be. The soil tends to have a negative charge, sulfate tends to have a negative charge, does have a negative charge, negative doesn't attract negative, and so instead sulfate just sits there and kind of floats in the soil water. This tendency for sulfate to reside within soil water influences how sulfur is taken up, the major way that sulfur is taken up into the plant. And we want to talk about that. There are really 3 ways that any nutrient can be taken into the plant. It can be taken in through mass flow. That's water streaming into the plant and it just kind of comes along with it. It can come through diffusion. We'll talk about what that is. And it can come through root interception. Each one of the nutrients tend to be drawn into the plant by one of these rather than all of these. So let's start with root interception. Root interception basically means that the plant accidentally runs into a nutrient in the soil and it's then absorbed. You know, a little bit of the calcium, a third of the plant's calcium actually enters the plant in this way. But for all the other nutrients, and you can see this in the chart below from Purdue, for all the other nutrients, root interception really does not account for most of the nutrient movement into the plant. It is very rare that for most of the 16, 17 essential plant nutrients for plant growth, that we ever see root interception as the primary way that those are brought in. Calcium is, sulfur is not. Why would that be so? Well, it's because calcium is so much more prevalent in the soil than what sulfur is. Remember, our soils come from a limestone base, so there's lots of calcium carbonate, lots of calcium in the soil compared to everything else. And for that reason, root interception is a major pathway for calcium into the plant because it can simply just run into it left and right, while it's not so easy for it to run into it left and right when we talk about sulfur. The following graphic kind of helps us understand what we're talking about. I've kind of drawn a graphic that shows how easy it is for a root to come into contact with calcium as opposed to coming into contact with sulfur. So here's that root growing through the ground, and it happens, you can see here, to run into calcium. Remember, calcium is so much more prevalent than what sulfur is. Now, if we move that root over, just imagine it grew down into a little different spot, slightly over to the right, you'll see what happens. Here it runs into calcium again. Thus the reason again that root interception tends to be a major way for calcium to move into the plant. Let's move it over a little bit more to the right. Once again, real easy or easier for the root to hit calcium in the soil as opposed to sulfur. One more time. Here we go again. And finally, we get a little bit of root interception with sulfur. It was so much easier, several times compared to that one time, that we were able to have the root run into sulfur. Calcium, yes, you'll run into it with the root. Sulfur, not so much so. So, could it be diffusion? Nutrient movement from an area of high concentration to an area of low concentration. You have these little films of water within the soil between soil particles, and nutrients that move by diffusion actually just kind of vibrate through those little films of water. It accounts for fractions upon fractions of an inch movement for various nutrients. And the two big ones that tend to move this way are phosphorus and potassium. Nutrients that are held tightly by the soil tend to move by diffusion, this little slow fraction upon fraction of an inch movement from an area of high concentration to an area of low concentration in soil water. Well, sulfur tends to be sulfate. Sulfate tends to be negatively charged. The soil tends to be negatively charged. It really doesn't fit that sulfur is held tightly by the soil, and so we really shouldn't be surprised that diffusion is not the big pathway for sulfur movement into the plant. Let's just work our way through the list. We said root interception doesn't fit as a major pathway of movement for sulfur into the plant because we said sulfur just isn't prevalent enough in the soil for the root to accidentally run into it. We said diffusion doesn't fit because sulfur tends to be in the form of sulfate, and sulfate does have this negative charge. The soil has a negative charge, so it's not held tightly. Diffusion tends to be the way that tightly held nutrients are moved into the plant, so that scratches that off the list. What about that third thing, mass flow? Well, mass flow is nutrient movement into the root with the flow of soil water into the root. So the nutrient comes with the water moving into the plant, and this process moves lots of nutrients into the plant quickly. Nutrients that are prone to float in soil water tend to move into the plant through this pathway. So nitrogen, for instance, tends to move into the plant as nitrate with the water stream. Micronutrients tend to do the same way, and mass flow accounts for most of sulfur's movement into the plant because sulfate floats in the soil water and is just brought with it. That brings us to the end of session 2 of our sulfur series, our 8-part sulfur series. Next time, we're going to talk about the sources within the soil, the major sources of plant-available sulfur. We've talked today that sulfate is the major pathway into the plant. We said sulfate tends to get moved into the plant through the water stream moving into the plant, and we said that sulfate is not held tightly by the soil. Next time, we'll venture a little further into this topic, and until then, we look forward to more sessions with you as you attend Burris Agronomy U.